This is question number 14. This is one of our word problems. The loudness of a Bluetooth speaker, L, measured in decibels, and this is the key sentence right here, varies inversely to the square of your distance from the speaker. So loudness varies inversely to the square. The square means power of 2 to your distance. So our setup is going to be loudness varies inversely with distance squared, the square of your distance. When you are 8 feet from the speaker, that would be a distance. The loudness is 28 decibels. That would be a loudness. So 28 is going to equal K over 8 squared. Now I can solve for K. 28 equals K over 64, and therefore K equals 28 times 64. I'm going to need a calculator for that. 28, whoops. Let me go back to my home screen. Excuse me. Okay, back to my home screen. All right, create 28 times 64, and that gives me 1792. So K is 1792. Therefore, my model is going to be L equals 1792 divided by distance squared. And it says, what is the loudness when you are 4 feet from the speaker? So at D equals 4. Loudness will be 1792 over 4 squared, which is 1792 over 16. And I'll definitely need a calculator for that. 1792 divided by 16 equals an answer of 112. So 112 decibels. Number 14, an object's weight on the moon, M, varies directly to the weight on Earth, E. So my setup is going to be, since it's a direct variation, weight on the moon varies directly with weight on Earth. Neil Armstrong, the first person to step on the moon on July 20th, 1969, weighed 360 pounds with all of his equipment on and 60 pounds on the moon. So basically, it said that he weighed 360 pounds on the Earth and 60 pounds on the moon. We're going to use that to find K. So 60 is going to equal K times his Earth weight, which is 360. And now we can divide by 360, divide by 360, and K equals, we'll use a calculator again, 60 divided by 360 gives me 0.17. I'm going to round it to 0.17. Therefore, our model is going to be that the moon weight is 0.17 times the Earth weight. So the question asks us then, what is the weight of a person who weighs 186 pounds on Earth? So at E equals 186 pounds. So moon weight is going to be 0.17 times 186 pounds of your Earth weight. And again, I'll need a calculator. I'll do 0.17 times 186 pounds. And the moon weight is 31.62 pounds. So I'll put here 31.62 pounds. And this is the moon weight. This is how much this person weighs on the moon. Okay. And then finally, the last question. This is a combined. Okay. It says y varies directly with x and inversely to the square root of z. So we got to put that together as an equation. Y varies directly with x, kx, but inversely divide the square root of z. This is your formula to start with. Then they tell us, well, x equals 2, y equals 5 when z equals 9. So y equals 5 when x equals 2 and z equals 9. I'm going to use that to solve for k. You guys know the square root of 9 is just 3, right? K times 2 divided by 3. I think I would multiply the other side by 3. 15 equals k times 2. And then divide by 2, and k equals 7.5. That's my k value. So now we can write our model. Our model with our new k value will be y equals 17.5 times x times the square root of z. The last thing says this: find y when x equals 4 and z equals 16. So at x equals 4 and z equals 16. Y will equal 17.5 times x is 4 over z is the square root of 16. And we'll kind of just, actually this one's going to be an easy one. 17.5 times 4 divided by 4, and the 4's cancel, and we're left with 17.5, and that is my combined variation.